In this video, we solved problem number 5 from quiz number 1 from the spring 2021 semester for Math 2613 Elementary Differential Equations at Tulsa Community College. We're asked to find an implicit family of solutions to the separable differential equation, and we have this right here. So it looks like we almost have all the x's on this side and all the y's on this side, but we're not quite there. In order to make that happen, I will multiply both sides by dy. And dx dy times dy is the definition of dx, so those sort of cancel. And then we'll have a function of y times dy over here, but we need to get rid of this x squared as well. So I would divide by x squared. On both sides. Ooh. So now we have this sine of 1 over x squared times dx equals y cubed minus 2. And then we have a y to the 1/2 in the denominator times dy. So the variables have been separated. Now, after you separate the variables, you just want to antidifferentiate each side with respect to the variable that is on that side. Now on this side, I see the sine function has a 1 over x in it. That makes me think I'm probably going to need to use a u-substitution. So I would let u equal the inside function. U is 1 over x, or if you prefer, you can write that as x to the negative 1. That'll make it easier for us to compute the derivative. And then we'll compute the derivative. Now when we compute du, that's going to tell us whether or not this u-substitution will work. So I'll bring the power down, and I'll multiply by x to the 1 less power and multiply by dx. And if we rewrite that, we can see that that's negative 1 over x squared times dx. And we actually have a factor of 1 over x squared times dx here. And you might be tempted to think of that as an x squared, but it's not an x squared. It's a x squared in the denominator. So that matches this form very well. So let's multiply both sides by negative 1. And then we'll have this. So now everything up here can be written in terms of u. First, I'll rewrite it like this. Going to factor out that 1 over x squared. Now, since 1 over x is u, this is sine of u. And since 1 over x squared dx is negative 1 times du, I've got sine of u times negative du. If you want, you can pull that negative out front. And we're just computing that antiderivative. I'll bring my negative down. The antiderivative of sine of u is negative cosine of u. Typically plus c, but we're just going to let the c on the right-hand side absorb the c from the left-hand side. And then don't forget to back substitute. U is actually 1 over x. I think I left a lot more space than I needed to. So that's cosine of 1 over x over there. And that's going to equal whatever it is we get on the right-hand side. Now for the right-hand side, we see we have a quotient, and we have this y to the 1/2. So we can simplify this. If you have a sum or a difference of terms here and a monomial in the denominator, you can take each of those and divide by the monomial. So this is the same as y cubed over y to the 1/2, or the integrand is the same as this, minus 2 over y to the 1/2. And then because of our exponent properties, this can be simplified by just subtracting the exponents. So we'll have 3 minus 1/2, y to the 3 minus 1/2 over here. And then here you want to factor out the 2 over 1 and use this property. If you have 1 over a variable to some power, that's the same as that variable to the same power but negative. So this can be written this way. We have 3 minus 1/2, so that's y to the 6/2 minus 1/2 is 5/2. Factor out the 2 over 1, and then you'll have a 1 over y to the 1/2, which is y to the negative 1/2 there. And now you can just use the power rule for each of these. You want to add 1 to the exponent, so add 2 over 2, and then divide by the new exponent. Dividing by a fraction is the same as multiplying by the reciprocal. Then here, bring the negative 2 down. Then you want to add 1 to the exponent and then divide by the new exponent. Dividing by 1/2 is the same as multiplying by 2 over 1. Don't forget to add c. And so we'll have a 7 over 2 times y to the 7/2 minus 4 times y to the 1/2, or square root of y plus c. And we were asked to find an implicit family of solutions, so we don't have to try to get y by itself. So that means we're done. We just needed to do a little bit of algebra, a u-sub, or a u-sub on one side and a little bit of algebra and the power rule on the other side.